Hey, welcome to part 2 of our vector review. This is just another way we can look at it. In part 1 we looked at the algebraically. Today we're going to look at it more mechanically or graphically. So let's take a look where we have, remember, this time we're going to take r plus s. Now recall, vector r, don't forget the hat, is given by 4, negative 3, while vector s is given by 2, 3. And if we want to write these as a we can actually draw these as a parallelogram. You might remember this one as that head-to-toe method from physics. Head-to-toe method, okay? So if I were to draw vector r from the origin, starting at the origin, it would be like vector r would be going to the right 4, 1, 2, 3, 4, down 3, 1, 2, 3. There would be vector r, or hat. Vector s would be 2, 3. 2, right 2, up 3. 1, 2, 3. There's vector s. So what would happen now is, what would happen if I were to add these together? Well, to add these together, we're going to take that head to tail. We're going to take the tail of s and add it to the head of r. So basically, I'm just going to kind of like make a parallelogram. And if we do that, this goes right 2, up 3. Well, if I start down here, if I go right 2, 1, 2, up 3, 1, 2, 3, if you notice, it puts me on the x-axis. And I can kind of draw that parallelogram if you want. You might recall from physics then that the resultant vector is the part that's in the middle. There's our resultant vector, where we ended up at. And if you notice, the resultant vector, sometimes we call it the resultant vector, is going to be over 6, right 6, up 0. So it's going to be 6, 0. Now we can check that algebraically if we wanted to. If I did r plus s, that would become 4, negative 3 plus 2, 3. And if I add those together, we do get 6, 0. So it's easy to check these. If we subtract, we do get a triangle. So let's take r minus s this time. Well, if I start with r, now remember r goes to the right 4, 1, 2, 3, 4, down 3, 1, 2, 3. Now, if I want to subtract s, we're going to do the opposite. So we really want negative s, which is just negative 2, negative 3. So my original r will be right here. If I wanted to add s, this is the head. I'm going to put the tail of s onto r. But remember, I want to go in the opposite direction. I don't want to add it like I did here, where I did the same sign, where I went right 2, up 3. I want to do the opposite. I want to go left 2, down 3. So from my point, I'm going to go left 2, 1, 2, down 3, 1, 2, 3. And there we have our new vector. So this is negative s. Our resultant vector, starting from the head of the tail of the beginning, go to the head of negative s. And there is our resultant. And where does that put us at? Well, it puts us over at over right 2, down 1, 2, 3, 4, 5, 6. So my resultant vector, whoops, spelled resultant wrong, is just going to be 2, negative 6. And again, we can check that, verify that mathematically. Let's take r, which is 4, negative 3, minus 2, 3. And we do get 2, negative 6. Right there. Likewise, if we want to do the triangle, s minus r, the other way, well, this time we're starting with s. Well, remember, s is right 2, up 3. Here, this time, we want negative r. Well, we know r is 4, negative 3, so negative r will be negative 4, positive 3. Again, this is now telling me to go left 4 and up 3. Remember, my original was go right 4, down 3. Well, this is going the opposite way. So now I'm going to go left 4, up 3. So 1, 2, 3, 4, up 3. 1, 2, 3. And that's where we end up at. So there is S and there is negative R. And here is our resultant vector. So, and our resultant vector is going to be, where's that going to be? Negative 1. Whoops, I miscount. 1, 1, 2, 3. We won't tell anybody this, but 4. There we go, negative 2. So, negative 2. We won't tell anybody I miscounted there. 1, 2, 3, 4. There we go. Negative 2 and up 1, 2, 3, 4, 5, 6. Up 6. Sorry about that. Totally miscounted. Please be careful. I did not count right there. So, no comments, please. Thanks. All right, now, so there's my resultant. And again, we can check it mathematically by taking S minus R. So if we take that 2, 3, and we subtract 4, negative 3, be careful of signs. Remember, this just becomes negative 4, positive 3. If we're subtracting, we can change that to addition if we like to do that. This becomes then negative 2, 6. Well, we can also stretch, multiply, like 3 times r. Well, so if we do something like this, if I want to do 3 r's, that means, ready? Very simple. Here we are, 1, 2, 3, 4, down 3, 1, 2, 3. There's my first one. So there's r. If I did r again, right 4, 1, 2, 3, 4, 1, 2, 3. There's r again. And I just do the same thing. 1, 2, 3, 4, down 3, 1, 2, 3. And there's R again. So we just have 3 R's all in the same row. Like R, I'm a pirate. R, har, har. Or har, har, R. Because that was a pretty funny joke. And then you can find out the resultant is just the entire length of that. The entire direction. And it's that entire vector. Which will be 12 down 9. So this will be 12, negative 9. And of course, you can easily verify that because you can multiply vectors. 3 times r. And if I distribute, this becomes 12, negative 9. And there is our resultant. Now, vectors have some properties. So these are pretty easy to follow along. One, you can add vectors together. That's what we've just been talking about. This property should look familiar to you. This is that commutative property from addition, so they commute. Next, the order in which we add doesn't matter. Okay? Right? This is that associative property. If I were to add 3 of them together, I could take the first 2 to add them together first, or I can take the second 2 and add them together first. So the order in which we add doesn't really matter how we add vectors. 2, they have an identity property. If I take vector A plus 0, I'm going to get the original vector back. That's our identity property from addition. If I add the inverse of a vector, in other words, it's inverse A, negative A, I'm going to get 0, the 0 vector. Now note, this is a vector. I'm not saying it's going far, but it is considered a vector. It has length, it has direction. I mean, it's still considered a vector. This is that inverse property from algebra. You can multiply, right? If I have, you can multiply by a scalar. If I have C, D times A, I can multiply the C and the D together. C times D, and multiply that by the vector A. We can distribute vectors. If I have C plus D, remember C and D are not vectors. A is my vector because it has a hat. I can distribute that if I felt like it. AC plus AD. We can distribute. Likewise, we can distribute a constant to two vectors as well, which we saw. So I can get C times A plus C times B. And lastly, if I take, there's two more really. If I multiply a vector times 1, I just get A back. That's that multiplicative identity property. If I multiply anything by 1, I just get that thing back. But there's also another one, 0 times A. What if I take 0, multiply it by vector A? Well, it's the same idea. It's that identity property, it's that zero product property from multiplication. We get 0 vector. Again, this is a vector. Anytime we have a set of vectors, we call this a vector space. In other words, it's the set of vectors on a plane. Or space. We're going to get into three-dimensional vectors soon here too. So anytime we have a set of vectors, we call that a vector space. So we're going to hear that phrase quite a bit. I hope you enjoy these videos. I will hopefully get back on more. All right, enjoyed it. Bye-bye.